Hello everybody. So we have been discussing the CSIR Gate, IIT-JAM and TIFR questions and their solutions. So in third part, we are going to discuss few questions. So this question was asked in CSIR June 2013. So the major product formed in the following reaction sequence. So they have given four options. You can see the first step is the paracid, second step is the lithium aluminum hydride. So the role of paracid can convert ketone into ester, and the role of lithium aluminum hydride ester can be converted into an alcohols. And the first step you can see. So paracids, the oxygen insertion can take place to this side or to this side. So as I said earlier, you can count the number of hydrogen atom to this carbon and this carbon, and here there is no hydrogen atom, and here you can see there are two hydrogen atoms. So oxygen insertion can take place to the side carbon bearing less number of hydrogen atom, and this is the product. In the second step, lithium aluminum hydride, this is a cyclic ester. It can be cleaved to give an alcohol as a product. Hence correct answer is option B. So you can see option C. Here only CH2OH, and we can see here there are another carbon CH2, and this keto group has been reduced. So CH2OH. So CH2, here there is a CH2, and this also CO becomes CH2OH, and hence this is not possible, and D is also not possible. You can have option A and B as a correct answer, but look at the stereochemistry of this position. So the lithium, as we have discussed in the lithium aluminum hydride, this is hydride donor, hence this stereochemistry is possible. So the hydrogen should be from the back side. So hydride donor, here hydrogen, and this is the possible stereochemistry of the product. Here hydrogen is in the backside position. This is not a correct answer. So this question was asked in June 2013 for the following three-step conversion. So from A to B, the appropriate reaction sequence. What happens if I use manganese dioxide? This is a selective oxidation of benzylic or allylic hydroxyl groups into corresponding carbonyl compounds. If I use pyridinium chlorochromate, what happens? It can oxidize both primary and secondary hydroxyl groups. So I will explain the mechanism. So in the first step, MnO2, manganese dioxide, the selective oxidation of benzylic OH into ketone. So in the second step, there is a protection of keto group in the presence of ethylene glycol, and this keto group can be protected. And in the second step, PCC, pyridinium chlorochromate, so it oxidizes primary hydroxyl group into aldehyde. You can see this is a primary hydroxyl group, can be oxidized into aldehyde. If I use pyridinium chlorochromate, what happens? Both this secondary group can be oxidized into keto group, and this primary hydroxyl group can be oxidized into aldehyde group. But you can see in the product there is a protection of this keto group. Hence B and C is also not possible. What happens when I use Jones reagent? So Jones reagent is also used to oxidize both primary and secondary hydroxyl group. So hence D is also not possible. So the correct answer is option A. And look at this question. So this question was asked in CSIR December 2014. So the product formed in the following reaction sequence. So they have given dibol, diisobutyl aluminum hydride. So they have given four options. The role of dibol, we know this is used to reduce the keto group into an alcohol. Ketone into alcohol is a product. So correct answer is option D. So look at the option A. Here there is no aromatic ring, but in the options you can have the aromatic 5-member ring here. Hence, this is not possible. Look at the option B. Here, these alpha beta unsaturated carbon carbon double bonds are also reduced here, but this keto group is not reduced. Okay, so hence this is also not possible. Look at the option C. Here, so this alpha beta unsaturated positions are reduced and the keto group is also reduced. So this is not possible in the case of dipole. Hence C is also not possible. Correct answer is option D. So it will not do anything with the alpha beta unsaturated carbon carbon double bond. So this question was asked in GATE 2020. Among the following the suitable reagents. So look at the reactant and product. What transformation has taken place? So this keto group has been reduced into hydroxyl group. They have given four options. If I use hydrogen, palladium, plus carbon, what happens? Hydrogenation can take place. So this carbon carbon double bond hydrogenated, hence A is not possible. Look at the option B. So hydrazine used to reduce keto group, that is C double bond O into CH2. Okay, but this is not in the product, hence this is not also correct one. In the case of option C, sodium borohydride in cerium salts, what happens? This is chemoselective reduction. So it will not affect the alpha beta unsaturated carbon carbon double bond. It selectively reduces this keto group into alcohol. And option D is not possible because this is lithium in liquid ammonia used for Birch reduction. So this is not also possible. But if I use only sodium borohydride, what happens? Both alpha beta unsaturated carbon carbon double bonds are also reduced. But in the presence of cerium salts, so chemoselective reduction, that is a Lucci reduction can take place, can get, this is the product, major product. So hence correct answer is option C. So this question was asked in GATE 2020. The major product formed in the following reaction sequence. So the first step, look at this. This is Birch reduction. Second step is the ozonolysis. So they have given four options. So the first step, so Birch reduction because lithium is there, liquid ammonia and tertiary butyl alcohol. Second step, they have given one equivalent of O3, ozone molecule, and look at this, whether it is oxidative workup or reductive workup. So this is dimethyl sulfide. So we have discussed in the ozonolysis part. So this is a reductive workup. So look at this. So in the Birch reduction, so this is the product. And for ozonolysis to occur, there are two carbon-carbon double bonds. You can see, but ozonolysis can take place to the carbon-carbon double bond where electron rich is maximum. So in here, you can have, you can see this is ethyl group and methoxy groups makes more electron rich this carbon-carbon double bond. Here only one methyl group is there, and hence cleavage can take place here to give the reductive product. Since it is a reductive workup, you will get a keto, that is a carbonyl group as a product. Had it been oxidative workup, so in place of methyl dimethyl sulfide, if it is hydrogen peroxide, then you can get carboxylic acid as a product. Hence, correct answer is option C. So this question was asked in 2006 GATE examination, similar to the previous one. The major product formed in the following reaction. So they have given one equivalent of O3, that is ozonolysis. They have given four options. You can see. So ozonolysis can take place to this side or to this side. But ozonolysis at a faster rate in one equivalent, so the more electron rich double bond can get ozonized. So this is more electron rich due to the presence of methoxy groups. So methoxy groups are more electron donating in nature compared to this methyl groups. And in the second part you can see dimethyl sulfide, and this is used for reductive workup. You can get aldehyde as a product. Here there is ester. Had it been hydrogen peroxide, you can get carboxylic acid as the product. Hence, correct answer is option D. This is the correct answer. So thank you so much for watching my videos, and please subscribe to my YouTube channel for more updates. So thank you so much.